Hello, this is the second after the area sign rule, second recording. I would like to now look at the sign rule, and we're going to use the area sign rule to actually quickly prove this rule, because I always like to show you where these things come from. So if I have got any triangle A, B, C, remember how we always label these triangles when they are not right angle triangles. We label the side opposite the angle with a small letter. So I've got that. I've got ABC like that. And we know from the area sign rule that the area of triangle ABC is equal to a half AB sine of C, and that's also equal to a half AC sine of B, which is also equal to a half BC sine of A. So we have that. Now, because these are all equal, this is actually one big equation. I'm just going to actually remove this and just look at these three parts. Because it's one big equation, actually there's a number of equations. Actually, this is equal to there's a number of different equations here, but I can divide all of these through by A, B, C, A, B, C, A, B, C, and also I can multiply the whole equation through by 2, or multiply each one 2 times 2 times. The multiplying by 2 times cancels out the half, so I can do that. As long as I do it to the whole equation, I can do it. And here you'll see that your A cancels and your B cancels, and you just left with a C. Here your A cancels and your C cancels, and you just left with your B. And here your B cancels and your C cancels, and you just left with the A. So we have finally this formula, which is actually the sign rule. The sine of C over C is equal to the sine of angle B over the side B, which is equal to the sine of angle A over the side A. This is your sign rule. We can also write it because we can invert both sides. We can invert the whole equation over. We can take it. We can also rewrite this equation like this. Let me do it in a different color. Let me do it in blue. So we're going to get here C over the sine of C is equal to B over the sine of B, which is equal to A over the sine of A. And we use this form over here when we use this part when finding an angle, because the angle is at the top, and this one over here we do this one when finding a side. We use that formula. Now the important thing with using the sign rule, this is the sign rule, that it works really well when you have an angle, when you get given an angle and an opposite side. If you have those combinations, if you have A and A, the angle A and the side A, or conversely, if you have C, the angle C and the side C, or if you have finally B and the side C. If you have this where you've got a pair of the side and the opposite angle, the angle and the opposite side, then you'll find that the sign rule is often a good rule to use. Now we're going to do one or two examples with this. I'll try and just bring it up so that we can keep this sign rule, so that we can keep it in place and use it. Just hold on one moment. I'm just trying to find it. There we are. I'm going to just bring it up like that, so we've still got it. Okay, and we'll just do an example with it. Let's say we've got this example here. I have got a triangle like this, and let's call it A, B, C, and this is 41 degrees, and even though this doesn't look like it, it's 113 degrees, and this is 18 meters. Now notice we have this situation where we've got the angle and the opposite side, and this actually, the important thing to do here is to label all your sides and your angles. So because this is opposite B, this would be B, this over here would be A, and this would be C. We are actually asked to find the length of BC. We want to find this length over here, BC. So we're actually trying to find A. Now, because we are wanting to find a side, I'm going to use this formula over here, and I'm not going to use the whole formula. I'm not going to use the whole thing. I'm going to use just part of it, the relevant part. So I go through and I say, okay, this is what I'm trying to find. This is my side A, and I've got that, and I've got my angle B, and I've got my side B. I don't know anything about that. I don't have anything. So this section here will be the one that I'm going to use. So I can write that in. I've got B over the sine of B is equal to A over the sine of A. I substitute my numbers in here. I'm going to put B is equal to 18 over the sine of B. That's the sine of 41 is equal to A. That's what I'm trying to find, over the sine of 113. Because I want A, I'm going to try and isolate A, so I'll multiply both sides through by the sine of 113, and I'll get the sine of 113 multiplying here. Not very nicely written, but anyway, that will cancel with that. And using our calculators, we will calculate that BC is about 25.26. BC, which is A, is about 25.26 meters. So I'm going to say 25.3 meters long. Remember, don't forget the unit. That's very important. So that's when we wanted to find. That's when we wanted to find a side, and we use the sine rule. Now let's use another example here. Let's do another example. I'm just going to move it up a bit. Where now we're going to find the angle, and I'm going to use this example here. Say we have got this triangle, and we've got something like this, where this is 8 centimeters, this is 12 centimeters, and this is 28 degrees. Now say I'm given this and I have been given no labeling. Well, the first thing that we would want to do is label it. So I could label this A, B, and C with capitals, and obviously this would be B and this would be C, my small letter C. Notice here we've got an angle and an opposite, and we've got opposite side. We've got this pair, which shows me that the sine rule is going to work really well. We are wanting to find here, we're wanting to find the angle B. We want to find the angle B in this triangle. So this is what we are looking at finding, that one over there. Now because I'm wanting to try and find angle, I'm going to use this form of the sine rule. And I'll write it out completely. So sine of b over b, it's a simple formula really to remember, over c. And I see, what have I been given? Well, I know nothing about a. I don't know anything about the angle A or the side A, so I can just cancel it out. This is what I'm trying to find. This is B, the angle B I want to find, and I have got I've got the side B, and I have the angle C, and I've got the side C. So I'm going to use this section of the formula, and I'm going to substitute my values in. So we're going to get the sine of B, that's what we're trying to find, over 12 is equal to the sine of C, which is 28, divided by 8. Now here you can see, by choosing this form, my unknown, the thing that I want to find, is at the top, and that's why we use the different forms. We would use this form of the sine rule. I want to find B, so I'm going to try and isolate it. So I'll multiply both sides by 12 times by 12, and that 12 will cancel out. And so I'm going to get the sine of B is equal to this. Now I do that on my calculator, and you're going to get an angle of about, let's just do it, we're going to do, if you take your calculators out, you take the sine of 28 times by 12 times by 12, and then you're going to divide that all by 8, and you get here 0.704. Now you'd keep this value in your calculator, although you may want to write it there. To find B, you're going to push on your calculator, you're going to push second, the second, which is the blue button, second sine, and that gives you the sine to the -1, and then you'd go second answer, which is actually the minus sign. It's actually at the bottom part of the calculator, and you get your answer, close brackets, enter, and you'll get here about 44.76. So I'm going to say 44.8 degrees will be your answer for B. If I wanted to find A, if I wanted to find angle A, then A would obviously equal, because the sum of angles of a triangle add up to 180 degrees, would be 180 degrees minus the 28 degrees minus the 44.8 degrees, and we can do that on our calculator. 180 minus, I'm going to say minus my answer, and minus 28, and I'll get this angle A is equal to 107 degrees. So that's using the sine rule to find the angle. I'm actually going to come back a little bit later to this and show you a more complicated case of the sine rule, but we'll leave that for later. Thank you very much.